And I'd now like to invite Tom Abel to the floor. Tom was our director from 2013 until 2018. So take it away, Tom.
All right, thanks so much. Wow, tough act to follow. Anyhow, I really appreciate you all coming and giving me a chance. I'll only take a few minutes. And I thought I just want to share a few things that I'm really excited about right now. For me, it's a wild time. Of course, I came here to the Institute almost exactly 19 years ago. And, so this conference is telling me I'm old. My kid just passed driver's exam. That's telling me I'm old. My kid's going to college next Wednesday. That's telling me I'm old. But I also have a sabbatical I get to look forward to that I'm starting now. And so I can share a little bit of the science stuff that I'm excited about. And so I like to do computational cosmology, and I often sort of think of that, of connecting the cosmic microwave background with sort of all the cool stuff that happens later on in galaxies and stars. And so really trying to understand that whole history of it. And just making all these connections using physics and big computers. And so here's my big computer of the day. When I first came here, we spent quite a bit of money of getting a decent computer that got John Wise a nice PhD thesis and a number of our students at the time. This computer is better, and it cost a lot less. And this one just sits under my desk, but I'm kind of excited about it. It's got 2 terabytes of RAM. It's got 128 processors on it. It's got a really fancy graphics card in it. And it costs, like a car. It doesn't break the bank completely. But I'm excited because I can do simulations I did 20 years ago, but now with 1,000 times the resolution. And actually the analysis is also so much faster because of all the solid state drives. I'm having so much fun exploring 1,000 times more data faster interactively. And anyhow, so that's just so awesome. The other thing I'm excited about is that Slack took about 110 of these and sort of building a system, which was kind of the reason I originally was very excited when I was walked around the machine room during the interview stage. It's like, oh, we have big computing at Slack. But we now actually have a computer that I can use. And you saw in the last month, this red line, I may be overdoing it a bit. It's not all the way where I want it to be and stuff, but we can do work now in an infrastructure that is built for LCLS, for Rubin, and is really a lab-wide strategy. And so that's actually just extrapolating. There's many big expansions planned. There's a whole second building of the machine room that will be filled with this machine. And so it's an exciting time actually to do computing at Slack. And I have so National Geographic put out the magazine yesterday, and Ralph and I made some visualizations of this new first star simulation with 1,000 times the resolution of the simulation that we had the cover of National Geographic about 20 years ago. And so it's kind of funny how that came full circle at exactly at this time that I've been here 19 years. And we also did another huge simulation, which was one of the biggest ones. What was that, 2015, John? Something. Right. Even that one, I can run on my little desktop machine now. And that's what we actually did for this. And Ralph managed to do this visualization of it. It's in a way the combination of all the work that John and I did together to do follow the formation of the first stars, follow the radiation transfer, how the H2 regions around these first stars form, how they then explode, how they bring out the metals, and then how the next generation of stars form to build up the very first galaxies. It was all in preparation to understand JWST. And that's sort of the picture editors of National Geographic. They always worry, it's like, they show one red dot. And so they appreciate having a simulation to go along with that illustration to sort of give the context of how we think about these galaxies. And essentially, this red dot is like one of these blobs here. And everything else, this is roughly the region of what will later become the Milky Way. This whole idea of how you think about our galaxy when I was a baby is just crazy fireworks. There's just all these massive stars going off. And then all these things coming together to later become, the place we inhabit now. And yeah, so I'm just going to show a few brief pictures of a couple of these simulations I'm excited about, just because they have been blowing me away. So this is the halo in which the very first star forms in this region. And you see that's about 100,000 solar masses in dark matter. And I'm slicing through the gas density. And then I keep blowing it up by a factor of 16 each time as we go around the circle. Down here, we're sort of more solar system size. And in every stage, as I look, I can visually pick out the nature of turbulence. Is it more supersonic, as in this case, where you have material cooling and falling in the gravitational potential well and crashing into each other, where you see sort of larger density gradients, shocks that you form. Then as you zoom in the center, it becomes more transonic and subsonic. That has to do with the molecular hydrogen actually being very poor coolant. And so all of a sudden, the motions become closer to the sound speed. And so the little dark spots that you see, and you can sort of see on the outskirts of this one, those are actually vortex tubes in the material. Then three-body processes, a very fast chemical reaction, turn the whole cloud molecular, and all of a sudden it starts collapsing supersonically again. Things start running into each other. But eventually, again, the center slows down and very strong shocks can form. And actually, so this whole region here, that's all dissociated molecular hydrogen. And you have cold material penetrating into this hot envelope, making all these beautiful fluid instabilities. Those are all things the overall results are still the ones that we found 20 years ago, but the detail of exactly this sort of mushroom clouds and what you call Richtmeier-Meshkov instability, that's all new. And it's just a joy when you get to play interactively with that kind of data. Here's the same thing in temperature. It looks even prettier, perhaps. And yeah, there's just a few things I'm excited about. Here's the molecular hydrogen, and you can make crazy movies. And then perhaps just one more point. That was the first things in the universe, and we're doing this whole project of what I'm running on the machine here is more about the last objects in the universe. And that gives me a lot of chance to giggle about it, doing the first and the last objects. But we're running the universe into the very far future and ask, what do these island universes look like at the very end when dark energy has taken over completely and essentially nothing's changing at all anymore, just the distances between the few objects that remain. And so talk to me or Brian about this if you want to learn more. And let me just then, with one quick thing, what's sort of interesting, as you get older, as an institute also gets older, there was a number of things. We always had fun from the start, but there was a lot of things that were hard. I mean, initially, we didn't have the infrastructure, we didn't have the buildings. We're like, if you move the curtain, dust would fall down. That's up there 45 years, and it was really. But there's so many things with all the hard work of everybody here. That a lot of things are much easier now. We've got beautiful buildings. We even have a nanofab now. We have telescope access coming. We've got all this crazy amount of multi-wavelength data. I'll show you a bunch about the computing things I'm excited about, but there's actual partners. We have a computer science division here that we can work with. We have data science institutes, human artificial intelligence efforts on campus. None of these things existed, and there's sort of a whole base of relationships we've built, this whole network of people around the world that fortunately so many came back to celebrate with us this week. And then, of course, also all the goodwill of us working together. And I'm just thinking about the data control room, the Rubin data that will be breathing every day. It's just going to be a remarkable next decade for KIPAC. And I'm almost sad to go travel for a year first before I join in again on the big fun. Anyhow, thanks so much for everything.
Okay, thank you, Tom, for sharing some of those wonderful simulations. And on a personal note, I can say a definite highlight of my career has been a very short email from Tom offering me a fellowship here at KIPAC. And it's been an amazing journey ever since. So thank you on behalf of KIPAC for everything you've done.